Hello there, I'm joined by Michael from Cole-Parmer, who's going to tell us all about piston pumps. Michael, tell us, what is a piston pump?
Sure, so a piston pump is a pump with very high accuracy and very high repeatability over long periods of time. It keeps a good flow rate with variable viscosities and can handle medium to high pressures. These pumps are the preferred choice for long-term repeatability in both the lab and industry. There are two main types of piston pump technologies, a valve piston pump and a valveless piston pump. So if we look at the valved piston pump first.
Yeah.
So I like to think of these as a bit of a mix between a diaphragm pump and a syringe pump.
Okay.
So I think it's like a diaphragm pump because you have this cavity that you are increasing or decreasing, so the piston moves in and out and makes it larger or smaller.
Yeah.
And you have your valves like a diaphragm pump.
Clever, yeah.
So the cavity, as the piston moves in, the cavity increases and sucks your liquid in.
Yeah.
But the valve at the bottom has to open to let the liquid flow in, and the valve at the top needs to close to stop your liquid from moving out.
Okay.
Okay. So as the piston moves back, this top valve needs to open to push the liquid out and close here to stop liquid moving backwards.
Okay.
Okay. So that's the main kind of features of the piston pump as a diaphragm, and I like to think of it a little bit like a syringe as well, because you have this piston a little bit like a syringe moving in and out, and the smaller you make this area, so the smaller you make this, the actual pressure it can handle increases, a little bit like the syringe pump.
Okay.
So if you basically have a compromise. So if you make this small, your flow rate decreases, but your pressure can increase. And if you make it bigger, your flow rate will increase, but your pressure decreases.
Okay, so you can choose options with higher flow rates and less pressure, or lower flow rates and high pressure?
Exactly, yes. Of course, you can vary the RPM to make this go faster or slower, but there's only a certain degree to which you can do that. A lot depends on the size of that piston. Of course, you can have a more powerful motor to make it go faster and faster, but then that starts becoming more expensive and more difficult to achieve.
All right. So what about the valve-less piston pump?
Sure. So obviously with the valveless piston pump, we do away with the valves. And obviously the benefit of getting away from the valves is that there's less moving parts. So you can have a better chemical compatibility, and you have a longer service life because there's less chance of something breaking. Right. Now, the way these work is, well, actually, I've got one here. So if we want to have a quick look at it,
yeah.
The piston, as before, moves in and out.
Yeah.
However, what it also is doing is rotating. So it moves in and out, and as it does, it rotates. And it's got this little cutaway piece here.
Yeah.
So what's happening is that when it's moving in, the cutaway piece faces the inlet.
Yeah.
So the inlet sucks the liquid in.
Yes.
And it blocks the outlet.
Right.
And then it takes your liquid, turns around, and pushes it out again on the outlet.
Right.
So you have this kind of piston blocking whatever port it shouldn't be going through.
Yeah, and that's controlling the quantity every time.
It's controlling the amount, and it's stopping the liquid moving backwards. So in essentially doing away with the valves.
Okay, and why is this machine on the table?
So this is what we would connect this to. So this is a Masterflex drive, so we normally use this with our peristaltic pumps. However, with some clever adapters, you can put this pump on this drive, and it will work similar to how you would set your peristaltic pump. So you set your RPM to get it to move at a certain speed. So again, why are these pumps so good is because they are so repeatable. They will carry on moving and going on and on and on without stopping. So recently we had a customer come to us who wanted to for an art exhibition, actually. They wanted to drip some dye into a beaker, so a couple of drops every 10 minutes. But they wanted this to go on and on and on with nobody intervening for 3 months non-stop at the exhibition. So nothing could go wrong. It had to be accurate and it had to carry on going for 3 months non-stop.
Yeah.
And this was the first pump we chose.
Okay.
And yeah, that ran very successfully for 3 months. At the moment, it was in the Tate Modern. It's actually now moved to Spain. So it's at an art exhibition in Spain. So yeah, so it's a great little pump for that. One other extra little feature. This can be tilted. It's a bit strange. This here can tilt. So you can go this way, that way.
What would you use that for?
So the reason being is you can actually vary how much the pulse delivers by changing this angle. It's just like a fine tune.
Oh, I see.
So if I set
it's almost like a calibration.
Yeah. So if I set it to, say, the centre, the flow rate drops. And if I move it further and further out, the actual pulses, the flow rate, it will increase. Okay. So you've got kind of two levels. You've got this movement and you've got the RPM.
Right, and how does this compare to the gear pump technology?
In terms of flow rates, they are very similar, actually. And in terms of pressure, they're similar. But this one will give you pulsation. The gear pump doesn't give you pulsation. But having said that, this pump has the better repeatability. So it would just carry on low maintenance. And if you have a varying back pressure, so say something might happen downstream, might cause a slight blockage, this pump will carry on pumping at the same speed. The gear pump might drop a little bit. I think that's one of the main kind of benefits over the piston pump, although you do get the pulsation. So
Michael, to summarise about the piston pump.
Yeah, sure. So again, we mentioned some of the strengths. So it's very accurate, can achieve great pressure at low flow rates, long service intervals. We mentioned there high turn down ratio achievable. That means that you can set it at a very low flow rate or you can set it at a very high flow rate. It's got a good range. Limitations, again, similar to the gear pump actually, not so good with particulates. You can damage your piston. High shear, so it's not a gentle flow, it's a pulse. Yep. Cannot run dry. Some can, so you've got to be careful, but basically most of the time you shouldn't run these pumps without any liquid. Again, the pulsed output, some customers might not want that.
Yeah. Applications?
So, applications, I think it's where you need the good repeatability over long periods of time. That's where you'd see this pump come into its strengths.
Okay,
thank you.
Superb. Michael, thank you very much from Cole-Parmer, telling us all about these piston pumps. So if you've got any questions, as per usual, please do just contact the team and they will help you out.